Alright, GridMap Maker, Devlog number 3. Today we implemented essentially a hard reload system. So if we generate a quick grid here, and alright, so here's a 100 by 100 grid for 4 hexagons and 4 rectangles. And essentially we have that our container, our visual container, which contains all the visuals for our grid. And it's the same system. All we're gonna do is we're gonna insert these grid into the insert just use them randomly. So from the container, which has all these grids over here, we will insert for each hex or for each rectangle, we will simply use a random visual data. So here's our visual data. We now have to insert the data into the material property. So what that means essentially is that, as you guys know, each shader has essentially a main texture and a main color, right, over here. And so our visual data comes with those two properties, main texture and main color. And so if we go back to our container, we have the main texture, we have the main color. And so if the data has a texture, that takes priority, right? If there is no texture, then we use color. Or I should say that if the color is white, then we use the texture, right? If the color is not white, then we use the color. So if we take a look at our shader over here, it has to be white. Then we can use the texture. And then that's it. So we just insert it, and boom, instantly it loads it. Um, Essentially, is extremely instantly, right? Let's see. So let's say we have down here we have snow, right? Let's say I wanted to make this grass, right? I can easily change this back, grass, instantly, right? This will allow for our users to instantly update their mesh on the go, without having to, you know, stop, pause, and all that and whatnot. So you can, and additionally, if I want to make a new visual data, just add over here. Let's call this red. Let's make this a red color. I just set this to null, and then boom, insert into mains, and then we would have to then regenerate the grid though, right? Because remember, it's already been created, right? We've already created them, so now we have to then generate the grid, give it some time to load, and boom, there it is. So now it's red. And again, back to the situation. Let's say I wanted to make this yellow, right? Excuse me. If I wanted to make this yellow, just do that. Boom. It's that easy. If I want to make it green, green. If I want to make it blue, blue. That's it. If I wanted to make it a texture, so I'm gonna make it water instead. Water. That's it. And oh, look at that. That's actually doesn't. Oh no, the color has to be white. Remember, the color has to be white. So yeah. So once the color is white, see, if it's not white, blue. If it's white, because it uses the water texture. And again, remember that the end goal of this is that the user will not be bound to a specific material, right? So essentially, once the user uses this, they can use their own material. Sync's main texture and main color are essentially universal to all materials, universal to all shaders. We can add them in here, but down the line, I think the user should be able to just use their own what do you call it, their own material. And given that situation, I think it's best for this shape visual data to actually be an abstract class, right? That way they can actually, what's the word? They can inherit from this, and in a sense, do I have a spray code somewhere? Do something like, do I want to create this? Let's just do it. So yeah, let's do it here. So essentially, they can do that, and then they can do like, all right, class custom visual data. Then they can just inherit from that shape visual data. All right. Now I'm just doing an example, but they implement those interfaces, and then that's it, right? That's essentially what they can do towards the future. I think, and towards when they download the asset. But for the time being, I think what we have now is pretty good. I think we should, but we should implement this visual data as an abstract class. And this is pretty much it for this devlog. Hard reload has been set. Everything's working. It's very fast too, by the way, guys. Let me just show you a quick speed real quick. So let me show you how it works first. Actually, all right. So of course you have the visual data, right? And essentially it has this delegate, which is the delegate over here, visual exchange. And so whenever we change the data of the whenever I change one of these properties, all we're doing is we're simply gonna raise an event, right? Boom. So this event gets raised, and then we have these layered meshes. And remember, our layered mesh contains a dictionary of the shape, visual data, and a fuse mesh, right? And so for every unique fuse mesh in our dictionary, we add, what do you call this? We add, we subscribe to the event, and upon event change, we simply, when the event changes, yada yada yada, do some, we make sure that it's going to be unique, and then we serialize the data. I'll show you what this means later. But essentially, once that visual changes, we come down here and we update the mesh. The reason why we do this only with the Unity editor is because I don't think in the build we were doing this all that much. But yeah, essentially every time it's a change, you update the mesh. And then we have this serialization. The reason why we have some serializations on this is because, as you guys know or may not know, Unity does not serialize dictionaries, right? So if we were to say save this, so if I were to make a change to the code and save it, this data will be lost, right? So what we have to do is that we have to then serialize the data in the dictionary into a list, which we do down here. So we have these two lists down here: shape visual data and the fuse mesh. On one thing you must know is that for your meshes cannot be serialized, guys, right? Meshes cannot be serialized. So, but what we can do is that we can actually just store the value of those meshes, right? So instead of storing the mesh itself, we instead just store the value of the mesh of the meshes, like the vertices and the triangles and whatnot, right? And then we have this delay call here, and this delay call essentially waits for all of the like Unity methods to run, because for example, you cannot create a new mesh during a serialization process, so you have to wait for that to finish. So once we have stored all of our data and we are waiting for all of the processes to complete, we can then add them back into our dictionary, the data and the mesh, and just draw it again. And remember, and then to show you how fast our method is, our methods are. I've actually tested this, but I'll show you some more. So the hardest part is to combine these meshes, right? So to combine all our meshes, remember that this is all here is a 100 by 100 mesh for each grid. So this the hexagon grid down here, this is 100 by 100, and this one down here, this is 100 by 100. And to show you how fast, and I take it, let's assume that for each hex, for each data, they take up roughly 25% of the hex. So what we're talking about, actually, we can just look at it. This is right here. So each submesh has an average of 10k triangles, okay, and 30,000 indexes. So that's how much we're dealing with right here. And to show you how fast it is to actually combine them, I actually tested this. So as you can see, it's essentially it's almost instant, right? And if you don't believe me, let me just do here real quick. Stopwatch, watch. Just the stopwatch. That's start new. You can just start new, and then I have a method for this log timer. Just log timer unbind mesh in time, and then you just pass in the watch dot ellipsed milliseconds. And just to make sure that you guys, I just to show you guys that this method is all this method does is that we simply parse the timer. So if it's in seconds, we just divide by 1,000 and whatnot. That's all we're really doing here. And if I save this right here, if I save this, well, what have I done? What's going on? Cannot create instance. What have I done? What have I done? Oh, it's abstract. There you go. It's like for a second I was like, okay. So if I save this, this should still stay. Our mesh over here should not delete itself because I have properly serialized it. right? As you can see, it just ran. And to prove to you guys that it's that it takes that our combination is almost instant. Remember, I have 100 by 100 grids here. All right, so let's make the yellow. Let's make the yellow pink. All right, let's insert this real quick. No, it doesn't work. All right, I messed up somewhere. All right, never mind. I lied. It doesn't work. Let me regenerate this. So guys, let's look at that 0.4 seconds and 0 seconds. Then if I come down here and I mess with this, 0.1 seconds. So yeah, it's extremely fast. Extremely fast. The numbers here, it's essentially not even a problem you should worry about. In fact, I can actually just do this instantly. If you look at it, just do it instantly. So yeah, and that's gonna be it for this devlog. There's still some slight bugs with serialization because like meshes are kind of weird because whenever you serialize them, they lose reference. I think you just saw that a minute ago. But by and large, we're making good progress. I think after this, our next step will be um. I think our next step will just be actually to add this to a grid to a chunk. To actually create a map and create a proper chunk with these things. And all right, there we are. You have a good day. I like the video by the way, guys.